So let f of x equal the absolute value of x minus 3 minus 1. And then just like yesterday, we're going to be writing g of x's. So don't let f of x, g of x, h of x, or any of that stuff confuse you. Those are just ways to name different functions, right? Just like we have different names. If I called you all Kyle, we would get confused about who I was calling on. Okay. So we all have different names. It makes it easier for us to call each other out who we are. Okay, same for functions. F of x is going to be our original function. G of x is going to be our new function. Okay, we're going to reflect it in the y-axis. If you reflect it in the y-axis, do you make y negative or x negative? X negative. So I'm going to do my function notation. G of x equals, and in function notation it's f of negative x, which just means I would go to this f of x. Wherever I see x, I will write negative x. So that will look like g of x equals absolute value, negative x minus 3 minus 1. I don't change any other signs. I only put in a negative x where I see x. This is a fine answer. Now, side note, if you can do the absolute value of a negative, an absolute value of a negative is always going to be a positive. So you actually can simplify this one, okay? Because, if you look at these two values, they're both negatives. So you could factor out a negative. So this would be g of x equals the absolute value of, and then you would have negative 1 times x plus 3, and then your minus 1 in the back. And with absolute value, for this negative 1, the absolute value of this negative 1 factor is always going to be 1, right? So I could then simplify it to be g of x equals the absolute value of x plus 3 minus 1. These are going to be, if you went on Desmos and you graphed these are going to be the same graph. Okay? I accept the first one. So you don't have to do this factor out a negative thing. But every now and then it pops up later, in a higher level math class, where you might wonder how they just got rid of the negative. And it would be through factoring and then doing the absolute value of the negative 1. Okay, so on a side note, that's also acceptable. Okay. Let's do the same function, but let's reflect it in the x-axis. So f of x is still absolute value x minus 3 minus 1. Are you changing the x or the y value when you reflect in the x-axis? You're changing y. So g of x in function notation is equal to negative f of x. And we want to do negative y, all of it. So for purposes of notes, I'm going to show my work here. I'm going to put a negative in front, and I want to make this whole thing negative. When I do whole thing in math, I use a group of parentheses. So I'm going to say parentheses, absolute value x minus 3 minus 1. Close my parentheses. And then, if I have different terms, I can distribute this negative. Now, one thing to be careful of. This x minus 3, because this isn't like a set of parentheses, this is an absolute value, it's protected by absolute value. So when I distribute the negative, it's really just going in front of the absolute value. It's not going inside the absolute value because it's not parentheses. It just sits outside. But I could also distribute it to that minus 1, which is going to turn into a plus 1. Okay. So g of x equals, it will be negative x minus 3 plus 1. I would would say a lot of us, when we're doing those reflections, we probably don't need to write this middle line. You'll just like distribute the negative to all the terms. Which is totally fine, but I just want to, in our notes, point out that essentially you are distributing it, but never should you distribute into absolute value. That's not the same thing as a group of parentheses. Numbers, negatives, don't distribute it. Okay, questions on reflections? Okay. Let's see, we want to do vertical stretches and shrinks. So the function notation for vertical stretches and shrinks, you did this back in geometry, and I'll have to talk to your geometry teachers. I don't know if you called them like dilations and compressions, or dilations. Does that sound familiar? Emma's saying yes. Okay. These are things where like basically you multiplied some shape in geometry by like a scalar. So then all the vertices moved bigger or smaller, and so your shape was a similar shape, but it was bigger or smaller. Sort of the same idea here. Vertical stretches and shrinks are just putting a scalar in front of y. So the notation for vertical stretch and shrink is the same for both. If you see a number multiplied by the y, the whole function, or if you're being asked to vertically stretch or shrink, you put a scalar in front of the whole y. It will be a vertical stretch or a shrink. How will you know which one? Based on the value of a. And this should make sense from what you saw happen in geometry. When your scalar is something larger than 1, it makes everything bigger. So that's a stretch. If your value of a is less than 1, and I say the absolute value is less than 1 but greater than 0, if it's like a fraction in between 0 and 1, it's going to shrink your graph. Make it smaller. Now, notice in those two inequalities, I use absolute value because I don't care anything about negatives in the front. What do negatives do? What did we just talk about? Flip, reflects. Okay, so a negative is always in charge of a reflection. It has nothing to do with shrinking or stretching. So if you have a negative 2, the absolute value of that is 2. It's still a stretch. Okay, even though negative 2 is smaller than 1, you're looking at the absolute value. I always tell people, like when you're thinking about vertical stretches and shrinks, to just think about like working in Photoshop. Could you imagine like putting your selfie in Photoshop? Beautiful picture of your lovely face, smiling. Okay. And then you know how like if you want your face to look normal, you have to pull on the corner so that it changes horizontally and vertically at the same time proportionally. Okay. What happens to your face if instead of pulling on that corner, you just pull on the bottom? Your face gets really stretched out, long and skinny, right? Okay. What happens to your face in your little selfie if you push up? Shrinks how? Your face has nowhere to go but out. That wide, right? Okay. So the same thing is true for our graphs. We're going to be concentrating on absolute values and linears in this chapter, but think about the absolute value of the v. If I pull it vertically, it's going to like come into itself. It's going to be more narrow and skinny. If I push the v down and it doesn't have as much place to go, it's going to like get really wide. Okay, we'll use the same f of x we used before, and we're going to practice vertical stretch and shrink here. Well, we want to write a new function, g of x, whose graph is a vertical shrink by a factor of 1/2. Now, if the factor 1/2 is less than 1 but greater than 0, it's a shrink. And the function notation for my new g of x is just to take that factor 1/2 times my whole function, f of x, right? That's a times f of x, where a is 1/2. So make a substitution. I'm going to show my work again on this one. I want to multiply it by all of f of x, so just like when I did that reflection in the x-axis, I got to protect it by a set of parentheses. It's the absolute value of x minus 3 minus 1. And clean it up by distributing 1/2. If it's absolute value, don't distribute into the absolute value. It just sits outside. So it's going to be 1/2 times the absolute value of x minus 3, and then minus 1/2. So I'm shrinking both parts, the absolute value part and then that minus 1, which would be like my vertical shift down one. Can you try the vertical stretch of 4? Okay. Same function that we were using by 4. Can you vertically stretch your graph by 4? Write that equation. What would it look like? I'm going to go ahead and write the function notation only because it's really good for us to get practice with function notation. We're not scared of it. We know what it means. It just means 4 times y, which if you're stretching vertically, you should be doing it to the y, right? Okay. But I saw a lot of people as I was walking around who just skip straight to their answer, right? They know they're going to multiply 4 by the x minus 3 absolute value and 4 by the minus 1. So it's going to be 4 times the absolute value of x minus 3 minus 4. I'm totally okay with that. I don't need to see the in-between line if you're comfortable with the vertical stretch. Okay. It's there in our first example, so we remember, oh, we're distributing, but we don't distribute into absolute value, but we don't really need to see it. I'm going to have you do one more problem with your groups. Okay. I'm going to skip the ones that are linear. There'll be some on your homework, but we'll have time to work, and you can ask the questions if you have any on linear, if they're not too bad. Can you work this problem with your group? So kind of discuss, compare, do you agree or disagree? What are you doing? Let f of x equal negative the absolute value of x minus 4, and then a plus 2. So I got a new function for you. And I want you to write a new function g of x that's a vertical stretch by a factor of 2, followed by a shift 3 units down. done one part. Okay, so even though I'm being asked to write g of x, I just called this one h of x because it's like in the middle of my work, right? So what I did first was I vertically stretched it by 2. So multiply the whole thing by 2. That will multiply with the negative in front, but remember I don't distribute into absolute values, so that stays x minus 4. I also have to multiply this last number, this k value, plus 2 by 2, which is giving me plus 4. So that's my vertical stretch of 2. And then I got to shift it 3 units down. So yesterday we talked about 3 units down from this h of x would be h of x minus 3 in the back, right? So if you think about that, it's not going to affect your negative 2 absolute value of x minus 4, but then you're going to have plus 4 minus 3, which would be plus 1. Okay. Now, question to prep you for one of your homework problems. If you did those in reverse order, would you get the same answer? No. Okay, you should be able to just kind of like see that right away. If you shifted it down 3 first, this number would become negative 1 in the back. And then if you did a vertical stretch by 2, that would end up being a minus 2, not a plus 1. So the order of those, if I say followed by, order may matter here. Okay, so you have to be careful with that. Okay, great job. Here's your homework assignment. You probably can't see it, but this is old Gandalf from, what's he from? Lord of the Rings?
Lord of the Rings and the
Yeah, okay. Okay, yeah. Okay. Numbers 11 through 18, 21, 27, 28, and 35. You can work on that now. We've got about 12 minutes, so I want everybody working on something algebra related. That could be your homework assignment. That could be your quiz corrections that are due tomorrow. Okay. Remember, those quiz corrections are going to go into your homework folder at 5%. It's going to be 10 points. I would love for everybody to start with 10 out of 10, but that means they have to take the time to do those corrections. They should be done in a different color ink on your quiz. You can use pencil and highlight them if you want, and just so that I can see where your new work is, so I look at that part. And I'll only be rechecking the ones that I circled, okay, because the other ones should be right. If you have questions on your quiz corrections, I'll be moving around the room and I can kind of address those. No. I check it when I walk around, and I give you your points for the day.